Hi, and welcome to the EvillGenius Kubernetes on Azure video series. I'm your host, Eddie Villalba, aka EvillGenius, and this series will focus on my best practices and tips for using Kubernetes on Microsoft Azure. More specifically, AKS, or the Azure Kubernetes Service, which is a service that we deploy in Azure. And then for those of you who are new to AKS, I'll give you a quick little overview of what that is. This series is going to focus on specific topics around proper implementation and usage of AKS. We'll focus about 20 to 30 minutes at a time, so it's going to be very in-depth specific topics that will go as deep as we can possibly go. And in some cases, I'll even provide code samples through my GitHub repo, which I'll link on my Medium page and also on the YouTube show notes down below. All the topics I cover are common tips and scenarios I've run into working with large enterprise customers over the last 2 years as a senior cloud architect on our global black belt team. I focus mostly on large enterprises across the globe, and we work specifically around implementing Kubernetes, AKS, or cloud native solutions in Azure. So all the tips and tricks are things that I found that are very common across all of these situations. So one of the things we're going to do in this, in terms of topics, what I'm going to cover throughout this series are things like from the basics, starting at networking, properly implementing AKS so that you can set up right the first time. How do we integrate with other services like Azure Container Registry, how to properly set up any other firewalls or load balancers in the environment. And then we're also going to kind of focus on implementation details. So little things like how I can deploy Istio or Linkerd 2 or Nginx proxies or Traefik. And we'll kind of go a little bit deeper as we go through the series. Again, I said I'm going to keep the series about 20 to 30 minutes at a time. And I welcome any comments or questions through either my Medium comments if you're coming through here through Medium, or my YouTube channel. In the comment section of my YouTube channel as well. So I'll be checking those. I hope to release these about once every 2 weeks, depending on my schedule. And sometimes I may be here at home or I may be on the road because I do travel quite a bit. So hopefully you'll stick with me, you'll watch these, and then even give me tips and tricks into how you're dealing with it. And also if you're submitting any work to AKS and maybe we can kind of collaborate on something. So what I want to focus on today is some of the foundational stuff. And one of the things that I've found quite often is networking begins to trip up a couple of folks when they're trying to deploy AKS clusters. When you deploy through the portal or through one of our CLI or any of the other tool sets that we can use to deploy into Kubernetes, into Azure, one of the things I noticed is that a lot of times you'll start off really quick and you'll just hit the defaults, and then as the cluster begins to grow or you want to productionize the cluster, things no longer work that way, and then that's when questions start coming up. So I believe in prior planning prevents poor performance. So I want to make sure that we understand the right concepts, the ideas, and how things are moving, and make sure that when you set up your environment the first time, it's the way that you really want it to set up. So today, we're going to talk strictly about AKS networking and the network concepts within both AKS and Azure, and make them how they work together. So I don't like doing too many PowerPoint slides, but I did put a couple together because I believe this is a good way of kind of explaining how they work. And then we'll dive into a cluster and showing off what it looks like in Azure, and even like the CLI and how to deploy those. So let's look at quickly. I just want to kind of go over first for the newbies out there to AKS. What is AKS, right? It is a managed Kubernetes service running on Azure. And what does it mean to be managed? Well, the control plane, the masters, all of the things that run in the master, the controller, the etcd, the API server, the scheduler, all those things are running in masters hosted by Microsoft, and you don't have to worry about it. You get an endpoint that you connect to. It's the same Kubernetes API endpoint that you would get with any Kubernetes distribution. And you can deploy your workloads through there using, whatever CI, kube control, whatever parameter, whatever way you want to send in work directly into the Kubernetes API. And then we'll schedule all the pods, and all the process will happen across a private tunnel to your VMs that are running in your environment. So those VMs, you get to pick the size, you get to choose what kind of VM type those are. And when you deploy your workloads, they're running on your systems. The nice thing is, administratively or infrastructure wise, we do a lot of the stuff that you don't have to worry about, right? Automatic upgrades and patches, high availability, reliability, secure scaling and easy scaling, self-healing in terms of the master, the control plane, and so on and so forth. And the cool thing is the control plane doesn't cost you anything. So all you're paying for is the number of nodes in your cluster. So it's very easy to kind of figure out what your costs are going to be for deployment of AKS in Azure. So that's the general gist of it. You've all seen managed services before, and it's very similar. Now, again, the thing is, everything that you put into Kubernetes, all the work that you deploy into Kubernetes, that's your responsibility. How you want to deploy it, what components you want to deploy, as long as it goes into Kubernetes and it works with Kubernetes, that's up to you, and you can do that. We're not going to pin you to a certain type of monitoring system or a certain type of service mesh or any of that stuff. That's up to you to deploy and how you want to deploy it, and we're more than happy to allow that process to go through. So when you create the AKS cluster, there's a couple of different ways to create this AKS cluster in Azure. First, obviously, you need an Azure subscription. If you don't have an Azure subscription, you can definitely sign up for a free trial, and I'll post a link in my show notes below. But you'll be able to go ahead and sign up for a trial and be able to set up a small cluster and run with it for a little while. And if you shut off your VMs at night, you don't get charged for them, so you can actually run your cluster for a pretty long time if you automate the shut off of your clusters, and there's a little option to do that. So when you set up the cluster, the first thing is, okay, I gotta deploy this cluster. Maybe I'm deploying it, say I'm an enterprise, and I'm deploying it in a network that is maybe given to me or provisioned to me by my network team, and therefore I have to make sure that my cluster will fit in the network that's given to me. When you're large enterprise, most of the time, you're either connected through some kind of VPN tunnel or BGP tunnel to your cloud provider. We have something called Azure Express Route, which is a WAN type technology to connect the Azure virtual networks that you create to your on-premises or your larger WAN, and then be able to kind of integrate the two clouds, the on-premise cloud, we call it on-premise cloud, and the public cloud. So when you have these kind of restrictions, you have to really understand, okay, well, what am I working with, and how big of this cluster am I going to get, right? And when it comes down to Kubernetes in Azure, there's two flavors of what we call the Azure, the container network interface, or the plugin, right? The network plugin for Kubernetes. One is called KubeNet. So you see here on the screen, KubeNet is basically the de facto network plugin that's included in all distributions of Kubernetes, in all Kubernetes. And it basically just allows the basic rules of pod networking, which means every pod can talk to every pod, even on the same node, across nodes in your cluster, without anything kind of running in the middle as a NAT or anything of that nature. And it's kind of like a flat network, right? Think of it as a very, very flat network. And it relies on the network provider, the underlying network provider, to take care of routing those packets to the right location as necessary. So one of the methods of deploying AKS is choosing KubeNet. Now, if you go through the portal process, you'll see there's two options when it comes to networking. There's something called basic and there's advanced. So what I want you to think from now on is basic equals KubeNet plus some defaults. Advanced is another network plugin, which we'll talk about in a minute, with no defaults, and you have to kind of select them, okay? So first, let's talk about KubeNet. When do you use KubeNet? You use KubeNet when you have a limited IP address space, and I'll talk about why that is, and I'll show you a graphic. When most of the pod communication is within the cluster, and you're exposing some of the services either through internal load balancers on your virtual network or external facing load balancers in your cloud provider, then KubeNet is a perfect scenario. And this is the kind of caveat gotcha. If you don't need advanced features like network policy management, today KubeNet on AKS doesn't support any of our network policy modules. That may change in the future, but today it does not. Also, we have a feature in AKS called virtual nodes. We're going to leave that topic to another session, and that basically requires us to use our advanced networking because of the way that the network works with that virtual node concept. Again, something I'll talk about in another topic. So if we look at the rules around KubeNet, right, there's a couple of things that we have to provide. If I go through the portal, right, so let me show you what the portal experience kind of looks like, and then you can see what I mean. So this is my portal experience. This is basically building a cluster through the portal. I've done some basic information, name of the cluster, the size of my nodes that I want, how many nodes I want in my cluster. If I want to use RBAC, we use something called service principals. Think of it as an identity that the cloud provider has, an IAM role in the cloud provider in terms of Azure that I have to provide to AKS so that when AKS does things that it needs to talk to the cloud provider, like create a load balancer in the cloud, modify some network components, it needs to act as this account. So we call that service principal in Azure. And we can either choose an existing service principal. So if your security department is what hands out service principals from your AD, then you'll get it from them. Or we'll create, if you have the rights, you as the user have rights to create service principals in your Active Directory, it will create one for you. And then the next part is networking. Okay, what kind of networking do I want? Let's go ahead and disregard this HTTP application routing for right now. I'll talk about that in a second, but usually, unless this is a development type environment, you want to choose no. This is not a production quality layer 7 routing process, right? It's mostly for dev test. But let's focus on network configuration. So there's two types of network here, basic and advanced. So when I choose basic, I get KubeNet. You'll notice I get no other options, 0. When I go to advanced, I do get some options here, okay? But let's go back to basic. Oops, sorry, got a bunch of birthdays today. So let's go back to basic. So what are the basic options here? Well, it doesn't ask me for my VNet, my virtual network, to place this in because we'll create one for you. And that's a problem for some, especially enterprises, because what we do is we create a large 10.0.0.0/8 network. So very large network space. And in most cases, it's an overlapping space with a customer's on-premise network BGP routes. So most customers, big enterprises, they're going to cover the whole 10.0.0.0/8 on their enterprise. And then that's what they're advertising over BGP. So the default network isn't great. So if you're going to build like a little sandbox cluster or isolated environment, it's never going to connect back to your on-premises. Not a problem. Works great. We also don't give you the option to change your service CIDR, to change your pod CIDR, to change your Docker bridge CIDR. None of that stuff, right? It's all kind of hard-coded. The trick is if you do it through the CLI, right, the Azure CLI, or we do it through some type of third-party infrastructure as code deployment tool like Terraform, then that changes. So let me show you what I mean. First, let me change over to my bash shell. So those of you who don't know, this is the Azure Cloud Shell. This is basically a shell in the cloud. It actually runs as a container in the back end connected to durable storage, and I can actually create stuff and save it, and I can use it here. But what's also nice is we include a bunch of tools. So in my Cloud Shell, I automatically authenticate because I've already authenticated to my portal. I've already authenticated to my Azure CLI, and I can go ahead and do calls. So AZ is the beginning of our CLI, and then AKS, and I can say create, and then we're just going to do a help on that one. And you'll see that we have a lot of options here on the create option, but you'll notice that I have a couple of options here. So let's go to alphabetically, right? The first thing I want to look at network specific is Docker bridge address. So you'll notice I can go ahead and specify a specific Docker bridge CIDR. We defaulted to 172.17.0.0/16, but we're going to talk about the rules in a minute. If that causes a problem and it's overlapping in an address space that's in your BGP, it may potentially cause some issues. So what we say is if that's a network that can potentially overlap with an existing on-premise network or something that's advertised through your BGP into Azure Networking, you might want to change that address space. Okay. Then another specific is the network plugin. So the network plugin first is which one do we want to use, right? And we can say either Azure, that's for the Azure CNI, which we'll talk about in a second, and then KubeNet, which is what we're talking about right now. All right. Network policy I mentioned. If I choose Azure, today we have in preview the ability to put in Calico as your network policy controller. And you can also set up Azure. So Azure Network Plugin, Azure Network Policy is you're using the Azure CNI's own network policy management plugin, or Azure as your network plugin and Calico as your network policy plugin, and we'll inject Calico in there. So just so you know, that's capable today as a preview. And then the other things that we have available is PodCiter. Now, PodCiter only really works when KubeNet is used. And you see that we highlight there, right? Assign pods IPs when KubeNet is used. And it's the CIDR notation that you want to assign so that your pods will get IP addresses in a specific CIDR range. And we'll talk about how that range is divvied up in a minute. And then service CIDR. So service CIDR is, again, what your service is. So when you do cluster IP and you create services in Kubernetes, what IP addresses will be assigned as the cluster IP, right? The internal IP address of that service. Again, some rules around that when you talk about hybrid connectivity or connecting to on-premises. And I think the only other one out there is DNS service IP, which is basically it's a specific IP address in your service CIDR, and we ask you to at least start by a .10. And again, I'm going to cover the rules in a second. But you notice that in the portal, I didn't have any of those options when I chose KubeNet, but when I deploy through the CLI, I absolutely do. And I can also use Terraform. So here, one of my favorite tools to deploy infrastructure as code, I have a Terraform sample, and here I can choose when I deploy my AKS resource. So this is my Kubernetes cluster resource. When I deploy my resource, I basically tell it what VNet subnet I want it to go in. And then under my network profile, I can choose my network plugin, again, Azure or KubeNet, my service CIDR, my DNS service IP, my Docker Bridge CIDR. And if I choose KubeNet as my network plugin, I can uncomment this here, and then I can put my pod CIDR in. And I just have those set up as variables as normal, right? So through the CLI, through any of the third-party tools out there that do Azure infrastructure deployments, Ansible, Terraform, even if you deploy through one of our SDKs, the Python SDK, the Go SDK, the Node SDK, you can absolutely manage that deployment process. One other thing that I want to call out is there is a max pods attribute that you can assign. I believe that's to the agent pool profile. And it would be right here under agent pool profile, where I can say my max pod number. And there's some defaults, okay? When you choose KubeNet, we default to 110 pods per node. This is an important number because you have to kind of understand the math that goes behind this when it comes to your IP address range. So with KubeNet, you get automatically 110 pods per node. When we go to Azure CNI, which is a next network plugin, it defaults to 30. You can adjust it. I wouldn't suggest going over 110, but you can adjust it up to the 110 if you want to. But again, there's math to be kind of done to figure out what's the right number. Okay, so let's go back to the rules around your CIDR address rules, right? So I want to focus on that. If I choose KubeNet, there are rules about my service CIDRs. If I'm going to customize my service CIDRs using the CLI or another tool, the service CIDR is basically an internal address space used by the IPs or by the nodes or the Kubernetes to give a durable service endpoint to your backend pods, right? It's default Kubernetes. So this is an IP address range that will be handled out. It should be an IP address range that is not in use anywhere else in your network, right? Or in the cluster. That means if you connect via VPN, virtual network, we call it VNet peering, so you can connect other networks together. Let's say you have no connection to on-prem, but you just have a bunch of Azure networks and you want to connect them together, VNet peering, same rules apply. Or if you're doing express route, which I said is like our hybrid connection process, you want to make sure that that service CIDR is not overlapping. Okay, the DNS service IP, again, I would start at the dot. We usually just say .10 of that, whatever that service CIDR is, for a good measure, and you're guaranteed not to cause any problems. And then you have the pod CIDR. The pod CIDR in KubeNet, you have to tell it what it is. And now the pod CIDR is actually broken up from a large space into smaller /24s. So it's important or critical that when you assign the pod CIDR, you can't give it a very small pod CIDR, because each node of the cluster is going to get a /24, right? So let's think about a cluster of, let's look at this diagram here. Okay, if I have a 2-node cluster and I assign the pod CIDR of 10.244.0.0/16, let's say, okay? So what's going to happen is each node in the cluster is going to get a /24 of that 10.44.0.0/16 network. So in this case, node 1, its physical node IP address is 192.168.1.4, okay? And that means the virtual network that it's connected to, there's a specific subnet for your nodes. That's the 192.168.1.0/24, and the node gets an IP on that address. Excuse me. Now, each node is going to get a /24 of the pod CIDR. In this case, the pod CIDR in this example is 10.244.0.0, let's say /16. So as it goes through, this will be 10.244.0.0/24, 10.244.1.0/24, and so on, and so on, and so on, and so forth. Now, pod to pod traffic here, if I talk from this pod to talk to this pod, no worries. It's on the same node. It's got a flat IP address space. So what about traffic leaving node 1 and going to node 2? How does that work? Well, we create a routing table in the Azure network, right? That actually says, hey, if you have a destination packet, let's say 10.244.1.0/24, you need to forward that traffic to IP 192.168.1.5. Right? If you have a destination packet, if the packet has a destination IP address of 10.244.0.0/24, then it needs to be forwarded to 192.168.1.4. Okay? And you can see that visibly here. I'll give you an example. I have a cluster here already that is basic networking. And you'll see the example I told you earlier. Here's the virtual network. There's that huge, large 10.8 network that was selected automatically. You'll notice that the pods, this virtual network has a subnet in it called 10.240.0.0/16. And that is the network for the nodes, okay, for the worker nodes. And if I go back here and look at, if I go back to overview, and I look at my node network interface cards, right? Each node has been assigned an IP address on that 240. Okay. Now, what we'll also have in this resource group is a route table that was created by AKS, or the deployment process when I deployed the cluster. And you'll notice this is what I was talking about earlier, where I have a 10.244.1.0, 10.244.2.0, 10.244.0.0, and they're each pointing to the node that's responsible for that broken up subnet, for that larger CIDR that's been broken up into /24s. So then that's how we route traffic between nodes in the cluster. And that's why it's important that your pod CIDR is not an overlapping CIDR, because the traffic from one pod to another on two different nodes will hit the Azure network, and it hits this UDR. And the way Azure Networking processes routes is that anything that's defined manually through a user-defined route table takes priority over anything learned over BGP and so on and so on and so forth. So you need to make sure that, we kind of follow the rules of the road and we don't overlap or we don't potentially override this. And so if UDR overrides BGP, and let's say you have a network on premises that is 10.244 and you need to access it. Let's say it's your database servers or anything that's on your premises are also 10.244. When the packet leaves one pod that's supposed to be talking to your database, and the database is on premises on a 10.244, when it hits the Azure network, because of this route table, that packet's going to be forwarded to whatever node that address falls into, right? So you have to make sure that those address spaces don't kind of overlap, because we're going to kind of hijack that because of the route table process, all right? Now, excuse me. So everything good so far. We have our pods, we have our node CIDR, we have our node, subnet that we created with our virtual network. We will automatically create the route table for you, so that's done. And as you add nodes to your cluster, we'll automatically append the route table. There is one thing: if you create an AKS cluster through the CLI or through Terraform, like I did here, at the end of the AKS deployment, the route table's created, but we don't assign it to the subnet. You have to go in and either through the Azure CLI or in the portal, you have to associate this route table to this subnet. It's a known issue. The team is kind of working on it to look at how we can automate that process on custom VNet builds. But just realize that when you deploy a cluster in AKS and you use KubeNet, and you customize the virtual network, you don't use this basic process, but you actually go into the CLI or you go in through Terraform or Ansible, you will have to go at the end of the creation to get your cluster to work correctly. You will need to associate the route table that gets created by Azure to the subnet that your nodes are on. Okay, and to find it, just so you know, when I create an AKS resource, the first thing is we create a resource group, and then that object, the AKS service, is put in there. But we also create another resource group, like a managed resource group, we call it, and it starts with MC. So you'll look for MC _, and then the name of your resource group that you're focusing on. So in this case, it's this one here. And then that's where my actual resources are. That's where my nodes are, the NIC, the virtual network, and more importantly, the route table. Okay. So KubeNet, route tables are involved. Remember the rules of the road. You have to get a pod CIDR that's large enough so that it can split it up into /24s, and it has to be large enough to accommodate the amount of nodes that you expect to scale up to. Okay, because once you deploy it, you can't change it, right? It's done. So you want to use some pretty good math. But the beauty is, going back to the benefits of KubeNet, is you don't have to worry about the IP space taking up on the space that was given to you. So let's say as an enterprise, you advertise over BGP all the 10 network. You can put all 172s for everything inside of Kubernetes because it doesn't matter. It's not an overlapping IP space. But your subnet has been carved out from an address space, a larger BGP address space, most likely, so that it probably does fall in the 10, so that you have a one kind of summarized BGP route for those of you into networking, right? And so most likely, out of the large 10 network, the enterprises will carve out part of the 10 that's not advertised on premises, but will be used as cloud space. And then that's what is divvied up amongst all the projects in Azure. And then you get a small portion of a 10. So you might get a /21 or /20. /19 would be even better. But let's say you get a small portion, you want to make sure and carve that up correctly and properly, right? Depending upon the size of your cluster. But KubeNet will make it so that at least the pods, which you can get hundreds of pods per node, and if a 10 node cluster, you can get thousands of pods. You want to make sure that you don't consume all of those valuable IPs that were given to you by your network team. KubeNet is the way to go. All right, so that brings me to the second. What if, hey, my network team is pretty flexible. They give me a pretty big IP address space. We have our own management, and we're pretty good about that. what if I want to use some of the more advanced things like network policy or virtual nodes, and I don't want to worry about this user-defined routing table? Well, the other plugin, network plugin that we have in AKS is Azure CNI. So when do I use Azure CNI? You have a large available IP address space, as I talked about. Most of the pod communication is outside the cluster. So you have a lot of like services. Let's say you have a bunch of microservices, but all the microservices are using some kind of eventing, and all of the eventing goes through some kind of queue like event hubs or storage bus or storage queues. And you want to, a lot of the communication is happening from pod to service, back, so on and so forth. You don't want to manage UDRs. They're too complicated. They add another layer of complexity. Maybe you have a very complex hybrid network with network virtual appliances in between and firewalls and so on and so forth. You don't want to have to add another layer of routing that could potentially cause confusion. And or you want to use some of our advanced features like network policy or virtual nodes. This is the right kind of pivot point as to say, I need Azure CNI. So what is Azure CNI's rules? Actually, they're pretty similar to the Kubernetes rules, right? You could define a service sider. Again, the service sider should not be an overlapping IP address space. It should be big enough for the amount of services you're going to deploy within the cluster. One thing I didn't mention before in KubeNet, and this applies for both KubeNet and Azure CNI, there are some reserved CIDR ranges that Azure uses for back-end kind of control plane management and other things. So you'll notice here 169.254/16, 172.30/16, and 172.31/16 are kind of like a no-no address space that you can use. You can't use that for any of your internal services. Okay, so don't overlap those because we kind of inject those automatically into the route table, and those are kind of managed services. And if you kind of remove that, or you use it, you could potentially cause some problems where your nodes aren't communicating with the master control plane, or DNS isn't working, so on and so forth. So just be careful on that. Again, the DNS service IP should be the .10 of the address space of your service CIDR. And now your pod CIDR goes away. You don't need a pod CIDR because technically your subnet in Azure that you create is the pod CIDR. So every pod will get an IP from the subnet that your nodes are on. Okay, so this is where real math gets involved. You have to build a network large enough to handle not just the number of nodes your cluster is going to be. So let's say you say, okay, I'm going to build a 20 node cluster. I'm going to max it out so I can do autoscaler. And I'm going to say from 20, it can max out to 50 nodes, right? So that's my scale min max, right? 20 is my min, that's my current working set. And then 50 is my max set at high demand load. I can scale up to 50, okay? Well, you have to kind of do math on that. Well, if at any point it can become 50, you need to kind of do some math. You want to make sure that, and the formula is basically the number of nodes plus one. The plus one means whenever we do rolling upgrades or when we do upgrades of Kubernetes versions, we actually bring up a new node first that has the new version of Kubernetes, new version of the operating system up, ready to go. And then we cordon or drain one of the old nodes. And then when that work has been moved off, we then kill that node. So that you have to have at least space enough to bring up another node. And you then have to have kind of a space enough to look at how many pods per node you've set in your configuration. So the formula is there, number of nodes plus one, plus number of nodes plus one times the maximum pods per node that you configure. So let's take that 50 node example, right? So again, let's say I'm going to max out at 50. Or in this example I wrote here is actually 50 node is my start, and I will allow scale up to 60, right? So 50 is my running set, 60 is my max on my cluster autoscaler. So how big of a network do I need? Well, in this example, 50 plus 10, so that's 60, plus 1, so that's 61, plus 61 times 30, 30 being the max pods per node setting, okay? And again, you can configure that, but the default for Azure CNI is 30. So if I take the default, 30, that's 1,891 IPs I need at least. So that's at least a /21. Okay, does that make sense? So you have to kind of do that little calculation. If I change that to 20 nodes that max up to 50, I still want to take that 50 as my max, but that's my max number. And I still want that plus one, and then I still get my 30. Let's say I go down to like, 10 node cluster and 20 is my max. And I would do 21 plus 21 times 30. And then I can, I think that would be like a slash 23, right? It's like 500 something addresses. So look at the math, look at this formula, use this formula as your kind of guidepost as to how big of a network do you need to set up in your Azure VNet. How big of a subnet do you need in your Azure VNet to carve out specifically for AKS? Okay, because AKS just cares about a subnet. So you have a VNet, lots of subnets in a VNet, but AKS only cares about the subnet that the nodes are going to go in. And this has got to be a blank subnet when you deploy AKS into something. There shouldn't be any other objects in Azure on that subnet, right? It's only dedicated for AKS. All right, so rules of the road. We talked about why you use Azure CNI, what the rules around the service side or IP addressing. And then the beauty here is we're just using the bridge process and we drop in the pod IPs directly on there. The biggest complaint about Azure CNI right now is that when I deploy something using Azure CNI, so let's look at another resource. Let's look at another cluster that I built. So here's another cluster that I have. This cluster is actually in precursor to my virtual node session that I'm going to do with you guys. This is a virtual node cluster. And you'll notice I have a resource group I created called VN-Demo2. This is my AKS object, but I also have a VNet object here, right? So that's a little different. Before, the VNet was created when I did basic. And it was pre-created, it was actually created for me, and it was put into the resource group that we automatically created for you, called the Managed Resource Group, or MC, okay? In this case, because I'm using Azure CNI, I want to pre-create my network for me. I created my network, and in this case, this is a bad example only because it's using the 10.8. But let's look, I have another cluster. Let me pick up another cluster here. I think this one is good. No, that's not a good one either. Hold on one second. I have way too many clusters, as you can see. Let's do this one. Okay, perfect. So here I have a network, and here I chose a 10.10.0.0/16. Not a great example, but it's a representative of a different thing than the default, right? So this is the network I created or pre-created is a 10.10.0.0/16. If I look at the subnets that I created, I only have one subnet. 10.10.1.0/24. Very small subnet. So this is just where my nodes are going to sit. But technically, it's also where my larger, all of my pods are going to sit. So the problem is I made this too small already. I can tell, right? So I have a subnet. It's a /24, very small number of IPs. If I look at the connected devices now, and here's where the problem is. Look what happens. When I choose Azure CNI, we automatically pull out or rip out 30, again, if we choose a default of max 30, max pods 30, I pull out not only the primary IP address for the node. So in this example, this node network interface, its primary IP address is 10.10.1.4, but it also took 5 through 35. And that is now owned by, or 34. That is now owned by that network interface card, that node. So we already pulled out. And then there's an IPAM module as part of the Azure CNI that will automatically assign IP addresses to pods. And then when a pod disappears and it no longer leaves that IP, the IPAM manager tracks that. So according to Azure Networking, we've already consumed all the IPs. It's already taken up, and then they're reserved for use by the nodes to give to the pods. So this is the biggest complaint so far, that we already eat up all of these IPs. And understood, it is what it is. So if I look at this cluster and I look at this environment, this is like a POC type environment. I've already kind of eaten up a large section or a large portion of my IP address space. So I can probably only scale this cluster from 3 nodes to maybe, 4 or 5 nodes total before I start running out of IP addresses, and still have enough headroom to do updates, right? So this is what I was talking about, making sure and doing your math and understanding the size of your cluster And it does take a little bit of pre-planning, which, unfortunately, you want to have a cluster that's very dynamic and you can grow and scale as needed, but it does take a little bit of pre-planning when you're using the Azure CNI. But the beauty here is, again, I can leverage Calico or the Azure Network Policy module, and I can then leverage all the stuff that's beneficial around the network policy management, around Azure SDN and or inside of Kubernetes. You'll notice that I don't have a route table anymore when I go into the actual cluster resource, right? So now I look at all of these, there's no networking objects, there's no route table, there's nothing there that I have to worry about. Everything else is kind of managed by Kubernetes and AKS in this example, okay? So kind of recap really quickly what, the two networking standards and when you use each one of them. KubeNet, you don't have a lot of IP addresses. You want to make sure that you have a lot of communication that's all kind of in the cluster, and you're only exposing services as you need to, kind of like pinholing services you need to. And you don't need some advanced features like virtual nodes or network policy. Remember the rules of the road. They're kind of similar. The only place they change is in pod CIDR. With KubeNet, you have to define a pod CIDR, and it has to be big enough so that you can be broken up into /24s. And again, it should not overlap with any of the other on-premise network addresses that you plan to connect to. And it should be large enough to accommodate the number of nodes that you're going to scale out to when you divide them by /24. And remember that we rely on a route table to take care of managing that traffic. Okay. And don't forget, if you customize your KubeNet deployment, always add the route table at the end of your deployment to the subnet. Okay. We'll create the route table for you, but don't forget to add the association. When do I use Azure CNI? I have a lot of IP addresses available in the cloud. Most of my pod communication is maybe from cluster to outside sources like eventing or message queues or storage blobs or something of that nature. You don't need to manage UDRs, or you don't want to manage UDRs because you have a very complex hybrid network, and you want to use things like virtual nodes or Calico or network policy module for Azure to do network policy management within the cluster. And again, the rules of the road, very simple. Remember this formula: number of nodes plus one, plus number of nodes plus one times max pods that you configure, so that you can figure out how big of an address space you need and still give you enough room to both scale and also do upgrades. Okay. And finally, the key also is when you do your deployments through the portal, you don't get on basic, which is KubeNet, or basic equals KubeNet, you don't get the option to customize all of those things. You have to do it either through a Terraform template, the CLI, or Ansible, or something of that nature, or an SDK programmatically, but you can't do it through the portal. And we do that for a reason. The portal is meant for just a kind of get started experience, okay? So we kind of make sure that you don't shoot yourself in the foot kind of situation. And then when you choose advanced, you're actually choosing Azure CNI. And here you can create your VNet, you can choose a subnet, you can change your service CIDR, your DNS IP address, and your Docker bridge. Will we ever change the basic in the portal to add those kind of things? We may. I'm not saying don't disregard anything. Input from you guys, the customer, and from the enterprises as to the experience you want will dictate how we drive the experience. So let us know if you want to see those advanced options even in basic. And kind of rename this to either KubeNet and Azure CNI to make it more conducive. But it's up to you guys. But right now, so far, we've been doing pretty good with the way it looks. And most enterprises are not really deploying things through the portal. They're deploying things, like I said, through that, either CLI shell scripts, or they're using Terraform, Ansible. I have some customers that are even doing like the Python SDK or Node SDK or Go SDK, and they wrote custom deployment code, which is kind of cool as well. So that's the skinny on Azure networking. Okay. Again, if you have any more detailed questions or very specific questions you want to ask me around this topic, or you have suggestions for new topics around AKS/Kubernetes on Azure, let me know and post them in the comments here in my Medium post, or if you're watching through YouTube, in the comments on my show. video, and I will try to get back to them. I'll try to answer you and or write them up as the next blog, the next video series. Speaking of next video series, most likely the next one is going to be working with now Kubernetes services and deploying services and what actually happens when you deploy a service with and you want to expose those services. So what are my options to exposing a service to the outside world? And when I say outside world, outside the cluster. So how do I expose it to an internal load balancer? How do I expose it to an external load balancer? And if I want to use an ingress controller, how do I set that up and what are my options in Azure? So with that, EvillGenius signing off. Thanks a lot for watching and looking forward to your comments or suggestions. Have a good one.